Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2024, Paper 2, Variant 2. In today's lesson, our main focus will be on electricity and atomic physics. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together. Let's improve together. Part B says a cell of electromotive force 1.8 volts and internal resistance small r is connected in parallel with a resistor of resistance 6.0 ohms and a filament lamp as shown in figure 7.1. The switch S is open, the ammeter reading is 0.25 amps. Determine the internal resistance of the cell. So first of all, we need to understand it is given to us the switch is open. So it means that we are just talking about this part of the circuit. So first of all, we can draw this line. So you can see we are just talking about this part of the circuit. And according to Kirchhoff's second law, sum of EMFs in any closed loop has to be equal to sum of TDs in any closed loop. So this is the main concept in any closed loop. So in this case, we have EMF that is equal to 1.8 volts. And we have current I times capital R. We have PD across this one. We can also draw voltmeter here. So we can say this is voltmeter 1. So we can say this is V1. And the reading on across this one, let's say here we have V2. But actually you cannot connect inside. But just for understanding, we are saying PD across this one is V2. So V2 will be equal to I times small r. So we need to find out value of small r. So we can say small r, this one will be equal to 1.8 minus I times r, and this will be divided by I. So that's all. Now simply plug in values and you will get the final answer. So here we have 1.8 minus value of current means current passing through this resistor, and this resistor is the same, and value of current is 0.25. Why current is the same? Because current coming from this side of the battery, it will pass through this one and also it will pass through this. So current is the same because they are connected in series, and value of current is 0.25 amps, and value of this resistor, this is 6 ohms divided by 0.25. So if we solve this one, we will get 1.2 ohm. So this is value of internal resistance. So this is how you can answer, and this question is very common in many past papers you will see. So you need to understand that EMF is equal to I times capital R plus I times small r. If we have this circuit, all components, they are connected in series. So this resistor is connected in series with this. So this is the main idea, and this question is very common in past papers. Part C says at time t1 switch S in figure 7.1 is closed. Figure 7.2 shows the variation with time t of the ammeter reading capital I. State whether the EMF of the cell after T1 is greater than, less than, or the same as it was before T1. We need to understand EMF is property of the cell, and that depends on the chemical reaction taking place inside the cell. So it does not depend on external components. So it means that EMF remains same. So simply we can say EMF remains same because that is property of the cell and that depends on chemical reaction. So we can say EMF remain same. It does not depend on external component, does not depend on external resistance. Second part says by considering the effect of the lamp on the total resistance of the circuit, explain the variation of the ammeter reading shown in figure 7.2. So this is our figure 7.2. So this is figure 7.2 and it is given to us. You can also take this one as a hint, considering the effect of the lamp on the total resistance of the circuit. explain the variation of the ammeter reading shown in figure 7.2. Mean how this ammeter reading is changing. You can see here until this point this current is constant. So what does it mean? It means that resistance is constant. So simply we need to understand this formula. EMF is equal to I times R total. So we can say this is R total and this is the total current. Initially we can see resistance is constant, means current is constant. So it means that if this value is constant, it means this is also constant because this is constant value. So this is one point we can write down. At time t1 you can see this current increases. So what does it mean? Let me rewrite this one. So here we have I and here we have R total, mean total resistance in the circuit. This value is constant. So if I increase, it means that resistance decreases. So this is the second point we can write down. And after that we can see this current is decreasing. So current is decreasing. So we can rewrite here EMF is equal to I times R total. So if I is decreasing, this quantity is constant, so it means R is increasing. But we need to understand resistance of this resistor is constant. When we close the switch, it means that resistance of the lamp is increasing with time. So this resistance is increasing with time because this resistance is constant. This is a fixed resistor. So that's all what we need to understand for this question and to answer this question. I hope this makes sense to you. Now let me show you the answer. In your answer you can write down these points only. First of all, you can say before T1 when current is constant, total resistance is constant, as you can see in this part before T1. And after T1, at T1 when current increases, the total resistance decreases due to decrease of external resistance. When we close this switch, total resistance decrease because this component is connected in parallel. So this is what is shown here. We have discussed this point here. After T1, temperature of lamp increases, so the resistance of lamp increases. So as resistance of the lamp increase, it means current is decreasing. Mean current is decreasing, so it means resistance of the lamp is increasing because this resistance is fixed. After T1, resistance of lamp increase, very important one, you have to mention this one. Resistance of lamp increases, not only the total resistance increases. So you have to say this resistance is fixed. As total resistance increases, it means that resistance of the lamp increases, and resistance of the lamp increases with temperature, and resistance of the lamp also increases with PD. So when potential difference across lamp increase, it means more electrical energy will be converted into thermal energy that will increase the temperature of the lamp, and as temperature of the lamp increases, it means resistance of the lamp will increase. This is very straightforward question and also a common question, but they have just asked you in a little bit different way, but it's a very nice question. So if once it is not clear, look at this question again and try to understand this question. This is very nice question and also a typical type of question maybe you will see in your coming exam. So then you can say total resistance increases, so current in the ammeter decreases. So if you write down these points, you will get 3 marks. So this is how we need to answer. Question 8, part A says, state the name of the class of fundamental particles that contains a neutrino. So we need to understand neutrinos, they belong to lepton family. So simply we can say they belong to leptons family, lepton. So this is how we can answer. All neutrino, they belong to lepton family. For example, we have electron neutrino, muon neutrino, tau neutrino, they belong to lepton family because they are not in the nucleus and they do not experience strong nuclear force because they are not in the nucleus. Part B says a hadron P has a charge of plus 1 E. E is the elementary charge. Hadron P is composed of a down antiquark and only one other quark. So we have hadron P, so it is given to us. This consists of one down antiquark, and the charge on this one is plus 1e. And there is another quark is here, so we need to write down possible flavor for the other quark. So the charge on this one is 1 over 3e. So this is the charge on down antiquark. Because the charge on down quark, this is minus 1 over 3e. So this is first thing we need to understand. Now the charge on this one has to be equal to plus 2 by 3e. So the total charge will be equal to 1e. So this one, this quark, this can be up quark, this can be top quark, and this also can be charm quark. So you can simply write down here, you can write down up quark, you can also write down top quark, you can also write down charm quark. So you can write down C, or you can write down charm directly. So you can write down charm quark. So this is how you can answer. For the second part, we need to state what type of hadron is. So we need to understand hadron. They can be classified into baryons. So we can classify them into baryons and into mesons. Baryons and mesons. Baryons, they consist of 3 quarks. Quarks are antiquarks, means they consist of 3 particles. And mesons, they consist of quark and antiquark. They consist of only 2 particles. So they consist of quark and antiquark. As in this case, we have only 2 quarks. It means that this belongs to mesons family. Mesons. So this is meson. Part C says nucleus Q undergoes radioactive decay to form nucleus R, emitting an antineutrino and another particle X as shown in the decay equation. State what particle is represented by X. So you need to understand, it is given to us antineutrino is emitted. Antineutrino. Actually, this is electron antineutrino. As this one is electron antineutrino, so this is antiparticle. So this one has to be particle, means this one has to be electron. So this one has to be electron, so we can write down this one has to be electron to conserve lepton number. So if this one is, if this neutrino, let's say if this one is antineutrino, so I will be writing here, if this is antiparticle, if this is antiparticle, this one has to be particle, and vice versa is also true. If this is particle, if this one is particle, so if this is neutrino, this one has to be antiparticle. So this is the main concept you need to understand, because these 2 particles, one has to be particle, one has to be antiparticle to conserve lepton number. So the main concept is, this is what you need to understand. So this is, so this combination is possible and this combination is also possible. So this is main idea you need to understand. Now in this case, if this is -1, let's say atomic number of this one is Z, mean it has Z number of protons, and mass number is A. So this one should have Z plus 1 and this one should have A. So we can also write down 0 here. Neutrino, they have no charge and also no mass number. So this is 0. Now question is asking us, say what particle is represented by X. So this particle, simply we can say this is electron. So this particle is electron, because in this case electron antineutrino is emitted, so this has to be particle because this is antiparticle. So simply you can write down electron. Compare the nucleon numbers of Q and R. Nucleon number. So this is representing the nucleon number A here. So this is also A here. It means they have the equal, or we can say they have the same nucleon number. Same or equal, you can say. Compare the charges of Q and R. charge on this one is Z, and charge on this one is Z plus 1, means charge on this nucleus is Z plus 1. So it means R has greater charge. So we can say R has greater amount of charge, greater amount of charge than Q. So this is how you need to answer, and I hope this question makes sense to you. And that's all for this paper and also for this video. I hope this video was helpful. If this video was helpful, please like and subscribe, because your encouragement is very important. If your teacher spare 1 hour, 2 hours to make a nice video for you, so your teacher also deserve your like and subscribe. So please like and subscribe, and also if you have any questions, you can leave your questions in comments and I will try to answer as soon as possible. If you're looking for extra resources, you can check Patreon. On Patreon, you will see a lot of resources, not only for physics but for other subjects as well. See you in next video.